Imagine a world made of tiny, invisible particles. These particles are so small that millions of them could fit on the head of a pin. Everything around us, from the air we breathe to the stars in the sky, is made up of these tiny particles called atoms. Atoms are the fundamental building blocks of matter. They are incredibly small, but they are incredibly important. The way atoms interact with each other determines the properties of everything in the universe. For many years, scientists believed that atoms were the smallest particles in existence. But as our understanding of the universe grew, we discovered that even atoms are made up of even smaller particles. These subatomic particles, as they are called, hold the key to understanding the universe at its most fundamental level. Let's dive deeper into the atom and see what secrets these tiny particles hold. At the heart of every atom lies a tiny, dense core called the nucleus. If an atom were the size of a football stadium, the nucleus would be like a marble sitting right in the center. Don't let its small size fool you. The nucleus contains almost all of the atom's mass. It's also positively charged, thanks to the presence of particles called protons. Orbiting the nucleus, like planets around a sun, are even tinier particles called electrons. These electrons are negatively charged, and their constant motion around the nucleus determines the atom's chemical properties. But the story doesn't end there. Protons and neutrons, the particles that make up the nucleus, are not fundamental particles either. They are composed of even smaller, more elusive particles, quarks and gluons. Quarks and gluons are fundamental particles, meaning they are not made up of anything smaller. They are the building blocks of protons and neutrons, and therefore the building blocks of all atomic nuclei. There are 6 types or flavors of quarks: up, down, charm, strange, top, and bottom. Protons and neutrons are made up of the 2 lightest quarks, up quarks and down quarks. Gluons, on the other hand, are the force carriers of the strong force, one of the 4 fundamental forces of nature. The strong force is responsible for holding quarks together to form protons and neutrons. Think of gluons like tiny subatomic glue that binds quarks together. This glue is incredibly strong, hence the name strong force. It's what keeps the nucleus from flying apart due to the electrostatic repulsion between the positively charged protons. Inside the nucleus, quarks and gluons are in constant motion, engaged in a cosmic dance governed by the strong force. Gluons are constantly being exchanged between quarks, binding them together in an intricate web of interactions. Imagine a group of dancers constantly throwing balls back and forth. The balls represent the gluons, and the dancers represent the quarks. The act of throwing and catching the balls keeps the dancers together, just like the exchange of gluons binds quarks together. This constant exchange of gluons creates a cloud of strong force energy within the nucleus. It's this energy, along with the mass of the quarks themselves, that contributes to the overall mass of the atom. Understanding this complex interplay of particles and forces is crucial to unlocking the secrets of matter. Section 5. Capturing the elusive, the challenge of imaging quarks and gluons. Visualizing quarks and gluons directly is an incredibly difficult task. They are far too small to be seen by even the most powerful microscopes. Furthermore, the strong force that binds them together makes it impossible to isolate individual quarks or gluons. Think of trying to take a picture of a fish swimming in a muddy pond. The mud represents the strong force, which obscures our view of the individual quarks and gluons. To overcome these challenges, scientists have developed sophisticated techniques to study quarks and gluons indirectly. One such technique involves smashing atoms together at incredibly high speeds. Section 6. A new era of nuclear physics, the first coherent picture. In a groundbreaking achievement, scientists have created the first coherent picture of an atomic nucleus composed of quarks and gluons. This remarkable feat was accomplished by colliding gold ions at nearly the speed of light. These collisions are so energetic that they briefly liberate quarks and gluons from their confinement within protons and neutrons. By analyzing the debris from these collisions, scientists can piece together a picture of the nucleus's internal structure. This picture, while still in its early stages, provides unprecedented insights into the arrangement and behavior of quarks and gluons within the nucleus. It's a major milestone in our understanding of nuclear physics and opens up new avenues for research. Section 7. Understanding the cosmos, what this picture reveals. The first coherent picture of the atomic nucleus confirms many of the predictions made by the theory of quantum chromodynamics, or QCD, the theory that describes the strong force. It shows how quarks and gluons are distributed within the nucleus and how they interact with each other. This knowledge is crucial for understanding a wide range of phenomena, from the formation of stars and galaxies to the properties of neutron stars, some of the densest objects in the universe. By studying the atomic nucleus, we are essentially studying the fundamental building blocks of matter and the forces that govern their behavior. This knowledge has implications for our understanding of the universe at its most fundamental level. Section 8. Future implications. Unlocking the secrets of the universe. The ability to create coherent pictures of atomic nuclei opens up exciting new possibilities for research. Scientists hope to use this technology to study the structure of other particles, such as protons and neutrons, in even greater detail. This research could lead to a deeper understanding of the strong force and its role in the universe. It could also have implications for other areas of physics, such as the search for new particles and forces. The journey into the heart of the atom is far from over. With each new discovery, we gain a deeper appreciation for the complexity and beauty of the universe we live in. Section 9. Conclusion: a giant leap for scientific understanding. The creation of the first coherent picture of an atomic nucleus composed of quarks and gluons is a testament to the power of human ingenuity and our insatiable curiosity about the universe. This groundbreaking achievement has revolutionized our understanding of the atomic nucleus and opened up new frontiers in nuclear physics. As we continue to explore the subatomic world, we can expect even more astonishing discoveries that will further illuminate the mysteries of the cosmos. The journey into the heart of matter is a journey into the heart of existence itself.